Scientific notation is a way of writing very large or very small numbers very quickly and concisely. What I mean by very large or very small numbers is if we look at our homework packet, we have a number like this one right here. That's a really big number, and it has a whole lot of zeros at the end of it. We as scientists want to write that number as quickly and as concisely as possible. Same thing with this next one where you have points, all those zeros, and a 4. That's a very tiny number. We have all these placeholder zeros in both of the numbers. So when we go to write our numbers very quickly and concisely, we have something called a coefficient. So just making up a number, something like 6.3 is my coefficient. You'll see a times 10, and then you'll have an exponent up here, so maybe something like a 4. What this actually tells us is we're going to take 6.3 times 10 4 times. So in your calculator you could put in 6.3 times 10 times 10 times 10 times 10 4 times to get the same answer, writing it out in standard notation. Now with your number, this exponent up here can also be a negative exponent. If we have something like 5.23 times 10 to the negative third, what that negative third exponent actually means is you divide by 10 instead of multiply by 10. So you have 5.3 divided by 10, divided by 10, divided by 10. What these exponents actually do for us is it moves our decimal place to the right or to the left 4 times or 3 times or whatever the exponent actually is. We know that if we have an exponent up here of 4, you're going to move your decimal place 4 times. If you have an exponent of 3, which is actually negative 3, but we're just going to look at the 3, we're going to move our decimal place 3 times. To figure out if we have a very large or very small number, if you have a 4 that's positive, that means that you're going to have a big number when you write it all out with all the zeros. If you have a negative exponent, you're dividing, so that means that you're going to have a tiny number or a decimal type number. So in this one, we're going to move our decimal place 3 times. 1, 2, 3. Drop in a new decimal. So we have 0.00523. We moved it from here 1, 2, 3 times. Or if we have this one and we want to make it a big number, we're going to move our decimal place this way 4 times. So 6.3, 1, 2, 3, 4. So you end up with 63,000. So looking at your scientific notation, if you give the scientific notation and you have to write it with all the zeros, you just need to figure out, is it a big number or is it a tiny number? And the big key thing to remember is you're going to take your decimal place and move it this many times, or you're going to move your decimal place this many times. Now if I give you a problem, something like 0.00064, or let's do another one like that, and we want to write those numbers in scientific notation. For this number that's out front, out here, that's called your coefficient. Your coefficient has to be a number that is between 1, so bigger than 1, and less than 10, so it cannot be a double-digit number before your decimal place. You can have a bunch of decimals after, but it has to be a single digit, drop in a decimal. So in order to get that value, you're going to take your decimal place. We read from right to left. Left to right. And as we read from left to right, we're going to approach it over. And the first real number that I see is a 6. I'm going to drop in my new decimal place after the 6. So I'm going to ignore all those zeros, and I'm going to write down 6.4. All of your scientific notation numbers are going to have times 10. This number is a tiny number. So with that number being a tiny number, you're going to have a negative exponent, and then we're going to have to figure out what is that exponent value. To figure out the exponent value, we're going to start at our original decimal and figure out how many times it had to move to get to our new decimal, which is 1, 2, 3, 4. So 6.4 times 10 to the 4th. On this one, same thing. We read from left to right. So we're going to find our first real number, which is a 7, drop in a decimal place after it. So 7.95. I ignore all the zeros because I want those to go away. So we're going to figure out how many times it took to move our decimal place from our new place to our old place. We didn't have a decimal written there, but it's implied that it's at the end of the number. So we're going to move our decimal place 1, 2, 3, 4, 5, 6 times. Exponent is positive because this is a big number. So looking at your scientific notation values, the big thing to remember is if this exponent is negative, that means that you started with a tiny standard notation number. If this is positive, you had a big number with a lot of zeros. Now when we get to our significant figures, we're going to keep sometimes some of these zeros or drop some of these away, but we'll get to that later on. For right now, for scientific notation, those are the big things that you need to know. How to go from standard notation, to scientific notation, or how to go from scientific notation to standard notation.